So in today's video, we are going to solve this problem. It's called cheapest flights within K stops. And in this problem, we are given n cities, and those cities are connected via some flights. So we are also given this flights array, and uh, the form it is given to us is like this: from, to, and price. So let's understand that with this example. So this flight is going to take off from this 0th city, and it will land in this first city, and the unit is going to charge us is 100. And you can see the other example also, they are same. And so basically we have been given this array and three more integers, that is source, distance, and k. So what that tells us is the source is the starting city we are currently, and the destination is where we need to reach, and what k is, we will understand that later. So let's walk through this example. In this example, we are given that we are starting from the 0th city, and we need to reach the third city, that is this one. So in this 0th city, we only have one option, that is this flight. We can take this flight and we can reach the first city. We can pay, and we will have to pay 100 units. After that, when we will reach to this city, we have two options now. We can either go to our destination, that is third city, or we can take this flight, which will take us to second city. If we take this flight and reach our destination, a total of 700 units we will have to pay. Otherwise, we can take this flight and we'll have to pay 100 units, and 100 units we have already paid. And then from here, we will again take this flight and we will reach our destination, and we will pay 200 more. So a total of 400 units. So this looks like a better idea, but there comes this K, which tells us that only we can only take at most K stops. So from 0, we have already taken this stop, which is the first unit, or first city, we should say. So when we have reached this first city, so K, we have already taken the first stop. And what this tells us now is that we have only one option, and that option is we need to reach our destination with another flight. So we will take this flight instead of taking this one, and we will end up paying a total of 700 units, and that's our answer here. So this was our problem. Basically, we just have to tell that what is the cheapest price we can take from source to destination with at most k stops. So this tells us the problem. Let's jump to the solution. Now we are at this city, the 0th city, and the total number of option we have here is one. That is this flight. So we won't think much. We will just take that flight and we will reach this city, the first one. Let's just forget about K for now. And from this city, when we reach this city, how many options do we have now? We only have two options here. That is this second city and this third city. So how can we know that which way will give us the better option? Uh, if we look from here, we don't know how much it will cost us from this second city to the third city, because we haven't reached here as of now. So what we will have to do is we will have to try all the options. We will first go from first to third, that just gave us 700, and we will also travel from first to second, and that will give us 100, and then from here to third one, that will give us 200. Also, we can again go to the 0th city, but it will be stupid thing to do because we have been already there. So this we can do. Now we just have to integrate k into it, and that just means that the person is saying that I won't take more than k stops from my source to destination. So now we are again at 0th city, and the total number of options we have is one. But this time we will think about one thing, that how many stop I have already taken, because I have not taken any stop and I have one stop of leeway, so I can do that. So I will go to first city. Now I have already taken the first stop, and at most I can take that first stop. So the only condition I have now is to reach my destination, and that is this flight. So now I have a total of 700 units. So that is our answer. And here to achieve that, we can apply breadth first search here. So what breadth first search is, from every node that is this city, we will try every option. So here we only had one option, so we will just go here. From this city, we will again apply every option. So we have this option and this option. So if we take this option, we will reach here, but we don't have any other city to go because we have already used our first stop. And if we reach here, that is we are already at our destination, and so this one will be our answer. Let's now come to the code. So the way this array flight array is given to us, it's not very useful because you see in when we are at this city, we have two options here. And the way it's telling us that is here. Tells us that from first city, we can go to second city and we have to pay 100 units. But now if I want to know other option that I have, I will have to traverse the whole array again. So when I will reach this place, this index, then I will be able to know. I don't want that to happen. What I want is I will just go to some index, and that tells me all the possible option that I have. So that's what we are going to do. I have a vector array here. It's called graph. It's actually called adjacency matrix. And so at that index, so let's again take this example. So when I will be here, I will say, okay, go to first index and insert 2 and 100 there. And then again, when I will reach this index, I will say again, okay, go to first index again and index and insert 3 and 600 there again. So when I will be at this city, at first city, I will just go to that index, the first index in my graph array, and there I will have all the options to go whichever city I have. So now let's go forward. So as we have discussed, to implement BFS, that is breadth first search, we use queue for that. And in this queue, we are just going to store a pair, and that pair will have price and where we are at currently. So we'll just insert 0 and source because currently we are at source and we haven't paid anything. So it will be 0. And also I have created this answer array. I will come to this later. The condition for the while loop will be that q shouldn't be empty and k should be more than equals to 0. And we will again, of course, keep negating 1 from k every time we reach here. And whatever possibilities we have at from this point, we'll iterate in that, and then we will take the current position and q and price from our this queue, and we'll pop it. After that, wherever we are currently, from there, wherever we can go, we will iterate in that. And the thing here is, this statement, what this means is, so the price of going to that uh, city plus the price we already have spent, if it is more than equals to this array that I have declared here. So this array, actually this is an array which will have uh, index between 0 to n minus 1, and every index will have a maximum number. So this will tell me that have I reached this place before or not, and if I have reached that place, then uh, what was the least amount of money I have spent to reach that city. And so this tells me that okay, if I'm going to that city via some route, so which whatever I have paid, if it is more than what I have paid earlier to reach that exact city, then I will continue. I won't continue with that, so I will leave it and I will go again iterate in that. If it is less, then I will okay. Then I will say okay. Just put that value in that answer array, and also I will push this price and the location that I am going to in this queue, and we will keep doing that. And in the end, I will just check if I am able to reach the destination. And the way I'm going to do that, this is actually a ternary operator. So how this work is, I'm just checking this is a condition, and this will be checked if answer of destination, if it is equal to int max. And if it is equal to int max, then it will do what? It will return -1. This is the return statement and -1. Otherwise, it will return this answer of destination, which will have the uh, smallest amount that we have paid to reach that destination. Now let's talk about time complexity and space complexity. So here in this graph, we have multiple iteration here. So we know that at any particular city, we can reach there from many other cities. We have a lot of possibilities here. So we can keep traversing. So that just tells us that we have, let's say, F is the number of flights. And also, because of this K, it is actually limiting us from traversing a lot. So we can just multiply it with K. This will be our time complexity. Yeah, and also because we have to traverse in N, so we can also give it 10. So now what will be our space complexity? For space, it will be same because we are storing this flight, and also we are storing it all in this queue. So it will be same as this one.